Alright, let's get into today's video where we're going to be talking about atomic bonding. You'll probably already know that an atom is the smallest unit of matter that is unique to a particular element. And that atoms are composed of protons, electrons, and neutrons. Now there are 4 types of bonding that you have to be familiar with in your studies, being ionic, polar covalent, nonpolar covalent, and hydrogen bonding, which is a type of intermolecular bond. Let's discuss ionic bonding in some more detail. So the IB defines ionic bonding as the electrostatic attraction between positively and negatively charged ions. Now you might be even wondering, what is an ion? Well, an ion is an atom that has either a surplus or deficit in electrons, leaving it with either a positive or a negative charge. More specifically, an atom that has gained an electron is said to be called a cation, while an atom that has lost an electron is called an anion. So in this diagram, we can clearly see a positively charged anion and a negatively charged cation that are electrostatically attracted to one another, which in turn forms our ionic bond. Moving on to our polar covalent and nonpolar covalent bonding. The IB textbook definition for covalent bonding states that the covalent bond involves the electrostatic attraction between nuclei of 2 atoms and the electrons of their outer shells. Pretty complicated. The main essence of covalent bonding involves sharing. However, it is important to differentiate between our nonpolar and polar covalent bonding. To put it simply, our nonpolar covalent bonding involves the equal sharing of electrons, while our polar covalent bonding involves the unequal sharing of electrons. In this diagram, we see that the blue cloud is representing the sharing of electrons between atomic nuclei that occurs in nonpolar bonding, whereas in the polar example, we see that the nucleus has a greater pull on electrons, so therefore has a bigger cloud surrounding it. Consequently, we see that the green atom is left with a slightly negative charge. Moving on to hydrogen bonding, which is a form of intermolecular bonding rather than intramolecular. So hydrogen bonding is defined by the strong attractive forces between the positively charged hydrogen atoms of one water molecule and the negatively charged oxygen atoms of another water molecule. And these bonds form due to the difference in electronegativity between atoms. It might be worth adding this to your notes. You might be wondering what electronegativity is exactly. Well, we'll define it as the ability of an atom to attract a pair of electrons towards itself in a covalent bond. You might be wondering how all of this links to the structure of water and indeed hydrogen bonding. Simply put, water gains its ability to hydrogen bond due to its polar structure. And the polarity of the water molecule is due to the fact that oxygen is more electronegative than hydrogen, thus exerts a greater force on the electrons. So the oxygen essentially pulls the electrons towards itself, much like a tug-of-war between the hydrogen and oxygen, where ultimately the oxygen is the strongest and exerts the greatest pull on the electrons. As a result of these differences in electronegativity, we're left with a slightly negative oxygen atom and 2 slightly positive hydrogen atoms. Let's finish up with some final pointers about hydrogen bonding. So 1 molecule of water can hydrogen bond 4 times. Finally, hydrogen bonding can occur between an atom of hydrogen and fluorine, hydrogen and oxygen, or hydrogen and nitrogen, which are 3 highly electronegative elements.